to you. Welcome to the University of St. Thomas and the first seminar for this year for the American Chemical Society Greater Houston section. Again, my name is Crystal Young. I'm the chair-elect for the Greater Houston section. I would like to introduce our speaker, Paige Marie Morse. She currently leads the marketing efforts at Aspen Technology, and she's going to tell you more about what that entails. She's also worked in the chemicals industry here in Houston at Shell and other corporations across the nation. And she earned her bachelor's degree from Kenyon College, which I hear is in Central Ohio, and got her PhD at the University of Illinois. She's going to be talking today on the digital transformation in the chemicals industry, and I hope we can welcome Paige Morse.
Thank you. Greetings. Thank you guys for coming out. Can you hear me okay? My voice is, yeah, okay, good. Appreciate you coming out this evening. Hopefully this will be an interesting topic for you. It's good to see the numbers here. It means you guys are curious, so that's good. I think digital we all know in our lives, but digital in the industry and what it means for the chemicals business, chemicals processes, R&D, is something that's really only just getting going with significant momentum. Called the digital transformation. And what's significant here is digital, as opposed to, you've heard maybe digitalization versus digitization. What we're doing now is digitization is when we started to convert things just into numbers to a digital format. Digital transformation means now changing how you do work. That's a big difference. You now have a new tool, so how you're doing your work is completely different. And so this is significant in R&D environments, and maybe you guys are beginning to experience that now. But it's huge for companies as well, because they have to redo processes and how they've always done their work and think about, now I have a new tool, I need my people in different places, or I need to design the unit that I've built a few of already, but now I'm going to build it differently because of these new tools. So it's making a big difference in the industry, hence the word transformation. It's really changing a lot of what's happening. So I'll talk about it now. I think we're a pretty broad audience here, so I'm going to try to hit the high notes, but you got a question, interrupt me, no problem, and we can talk about it some more, because I want to make sure people understand. And then if you're curious and want to know more, please do ask. I'll answer what I can. I may just say, hey, I got to talk to a colleague, and we'll pick it up from there, and that'll be fine too. So, okay, let's go from here. So, in the chemicals business, this has become a really big deal, as I mentioned. So these are just some quotes from big chemical companies. You guys are familiar with the names probably. They're saying, oh my gosh, this is big news, I got to do something different. Because really the digital capability has been around about almost 40 years actually in the chemicals business, but people have been using like in a small place, like, well, let me just try this little way, experiment, I'll do some screening technology and try a digital tool. Or maybe I'll try it in one unit and how I run a particular production unit. But now you're looking at across your entire business. So it means a lot. I got to redo everything. That's BASF, used to be the biggest chemical company in the world, kind of are, but really other companies are growing in other regions. Evonik is one of the big German companies that have done a lot of work. Maybe you've heard Industry 4.0. That started in the chemicals business through an initiative with the German government. So there's a lot of activity that started in Germany and then has grown out from there. And Evonik has been a big part of that as well. And then Dow, this is the CEO of Dow saying, business is completely different than what he's used to and what he's done before. So it's really interesting to see the changes. And I'll tell you, just for me, so I've worked in the industry since I got my PhD. I started in Shell research, and then I did my 5 years in the lab, and I knew I wasn't a lab person. It's okay, but it wasn't my thing. So I went into the business area. I did marketing, strategic planning, and kind of long-term capital planning as well for companies. And digital, I'll tell you, I've decided to go into digital because it's a huge issue for the industry. We got to figure out what it means. And I decided I wanted to learn it. And the best way to learn it is to start doing it. So what I do at Aspen is I help bring the needs of the chemicals business back to the company to say, okay, these are the kind of tools we need. And then on the other direction, I take the new Aspen tool and go talk to the chemical executives and say, let me tell you why you need this. How it'll change your business, how it'll help you make more money or help you make the product faster. Because these days, think about new products you want all the time. You're a new, like a healthcare product you want. There's a lot of medicines being made new all the time. or there's new shampoos and things like that, and you want the latest thing. It's a lot of work to make a new product, and if you can do anything to make that faster, it's a great opportunity for companies to make money. So that's why they're very interested in digital. It's also changing research. So this is a quote, this is just literally this month in the Times. It's not that machines are going to replace chemists. Maybe we all feel about chemistry in here. It's that chemists who use machines will replace those who don't. And I do think that's true. It's just a new tool, and you want to learn how to use this tool. And so it's a great article, actually. This specific article was about use in pharma, because they're using it a lot to do new drug development. And it's an area that's very competitive and takes a long time to do. So if you can get a digital tool that helps you work a little faster, a little better, maybe use less resources or be more efficient in your process, it's really important. So this is the kind of the drive now that everyone really wants to get involved in digital. So what does it really mean? That's the key here. So these are just some other quotes from externally. The World Economic Forum got very involved, and they are now. Last year they did their first effort in digitalization. This year they came out having done a whole bunch of studies across industries and all the value you can gain, and then just other things around the world talking about how important the digital efforts are. If you look at productivity, and you think about what digital does for that, this is obviously, these are big developments in industrialization and how we're increasing productivity. But now with the growth of automation, it's a huge change in terms of our ability to greatly improve productivity. So it's not that we'll be replaced, it's that we'll be more efficient in the work that we do. I mean, that's really the message here. But productivity is important, it does improve quality of life. And one of the key things now that it's just starting is robotics. Obviously, we're aware of that, but also artificial intelligence and machine learning. So I'll give some examples of that as well, because that's the newest thing that's now being applied to a lot of chemical processes. And what's particularly interesting here in these two, artificial intelligence and machine learning, is they're both based on data. And what chemical companies have done for years, and R&D organizations, is collect loads of data. And it may be initially written in your lab notebook, but later might get typed into a computer. But you've got loads of data, and you're only just beginning to learn how to look at it. And that's what artificial intelligence and machine learning are helping with now. You can look back at your data and go, oh, that's what it means. And I'll talk about that a little bit as well, because it actually gets a bit confusing. Sometimes when you have too many variables, you actually can't see the picture. And the digital tools can really help you with that. So let's just talk about the differences around the world. It's a little different depending on where you are. The US right now, we know here in Houston, the shale boom, we have this huge advantage in feedstock. And so we're building like crazy. But at the same time, we have a changeover in workforce. We've got an aging workforce who knows a lot, and some new people coming on who don't know as much. They haven't been running that unit for 30 years. So now there's an opportunity that you can take all the knowledge in that person who's got a lot of years of experience and put it into a computer program that captures the data the way it's been done for years to provide insight back to the next people who are going to do it. So there's a great value in digital tools for that. Particularly true in the US. Europe is a similar situation, but they also have a big challenge because their assets are older. In the US, we're building because we have an opportunity. It's not like that in Europe, but they have the same demographic challenge. So for them, they're trying to specialize as much as possible. What cool new molecule can I make that's different and be distinctive in that way? And so it's a different game. And then other parts of the world, a lot of different things. But the difference mostly with the other parts of the world is a lot more younger demographic. So you're going to have a less experienced workforce. Maybe a country is building a chemical unit or starting to do significant industrial or university research for the first time in Indonesia, for example. They're only just getting started. China's been building up quite a bit. They're just not talking about it as much, but they have been. But India, just getting started. They're starting to build really big new units, but they're still got a lot to learn. So digital tools can really help on the other parts of the world as well. Guys, cool? Following me okay? Yeah? Okay. And then this is, I thought, an interesting study. So this is good old, consulting group, Deloitte. So they go out and talk to executives, and they talk to oil and gas, that's in green, and the chemicals guys in blue, and saying, okay, you're going to do digital. How are you going to use it? What are you after? What are your goals? Not surprisingly, they want to make their assets as efficient as possible. How can I make that plastic most effectively? These days, that means use the least amount of material to make it, lower energy, and be sure I make the right stuff so I'm not making waste. So how can we be as operationally efficient as possible? A lot of digital tools help control your unit so you can make exactly what you want. You want to increase worker productivity for sure, and of course profitability. You're always trying to squeeze the last bit of profit out of it that you can. But innovation R&D is really important. And one thing I like to notice is it's chemicals, it's a lot more important. Not surprising, because I mentioned before, in chemicals, we're often making new stuff. A refinery is still just making fuels for the most part. But R&D is still really important in the chemicals business. So there's a lot of new tools being applied that way. Advanced manufacturing, this is the use of machine learning and artificial intelligence I mentioned before, and we'll talk a little more about that too. And then there's an emerging area too of how do we maybe sell chemicals on the web? BASF has just launched an initiative to do that. So that's a growing area where, do we want an Amazon for chemicals? I don't know, but that's some of the discussion right now. And part of it is just about it's easier to talk to your customers if you do stuff through the web. So that's one of the tools that's being looked at. But notice it's kind of a smaller piece of importance. There's still a big belief that it's about relationship and engagement and discussing huge chemicals. But there's a lot of other opportunity in how things are made and the other tools that you use. I just thought this one was particularly interesting. This is another of the big German chemical companies, Wacker. They talk about all the opportunities for where the money that can be made, what the value is for the industry, and the things we talked about a little bit in customers, R&D, digital plant, supply chain, making workers more efficient. But this is a really important area that's growing as well. They're also looking at it for what it can do for CO2 reduction. This is a critical topic right now. It's been a critical topic for quite some time. I think we're paying attention a little better now than we did. But there's also an opportunity to be as efficient as possible, which is then reducing your carbon footprint. And this is really important. Many of the models now are having built into them what's the CO2 impact, watching energy much more carefully, looking at alternative sources. Hydrogen can be a good energy source as well, and it doesn't make CO2, so there's a lot of things to think about. So I just think it's important that we consider it as well, that this is a good metric and a good way also to keep track of the CO2 situation. So I'm just going to give you a way to think about the different tools, and I'm going to show it in the way that my company usually talks about it. I'll have to tell you, I like things organized, so this makes sense to me. And when we think about what you're doing in a chemical process, so when you're preparing, let's say we're making a plastic. We're somewhere here on the Gulf Coast, and we're going to make polyethylene, so very common plastic. First, you want to design a unit to make that particular plastic. So you've decided what you probably want to make, you know what your feedstock is, so you design the unit the best way you can. Then you want to operate it as efficiently as possible, and then to maintain it as well as you can. So this is how we think about it, is that you get started, but you never stop using digital tools because the unit's always operating, you're always thinking about maintenance. Maybe you think about, I want to make it a little bigger, so you got to do another project. But it's really looking at the total life cycle, because these units, they can run for 50 years. So you really want to be thinking about how I use them the best way we possibly can. So this is kind of the way to think about the overall use of the asset that you're using for chemicals. So let's talk about design. So now I'm going to build the unit. But first step, though, is I thought that, okay, there's some really cool new polymer I want to make. And I think I know how to make it. Well, I made it in the lab once or twice, and it looked pretty good. The testing worked out pretty well. But what I want to do now is figure out how to scale it up and then build a big plant to be able to make it. Well, that takes a lot of work and a lot of time. There's now a lot of models that you can use where you take the basic process and you input, maybe it's an acrylate system that you're doing, looking at a variety of monomers to make an acrylic polymer. You can put in that detail into the model, and it can tell you, all right, in these are the optimal conditions. You think it's 85 degrees, but actually it does better at 82.5, and you need to watch the agitation in your unit. But the model can begin to tell you that and give you guidance. So it helps you do your experiments faster. Dow actually calls it model-based experimentation, because it gives them a little bit more insight as to how they do the processes. Because you can spend 10 years trying to develop something. But if you use models, it can help narrow that time for you, so you can be quicker in doing it. So the key is, yeah, it helps with budgeting, right? You're not working as long. but it gets you to market faster, helps you figure out what's the optimal process situation. And then you can build the unit that does that for you. Yeah.
When you say models, are you talking about like computational models?
Computational models, yeah. So not like stick models, yes, computational. Let me show you this next slide, like this. So you're building a unit. So online, you have a variety of vessels that you're using to make the product that you want. So you do it, now you've done some mock-up in the lab, maybe in the small scale or in a few of the steps, but now you're using the model to help you make the right decisions as to how you should do the process. So it makes you more efficient. Now, it still takes a lot of experimentation, but it helps you kind of smooth the edges, narrow you in much faster. So yes, it's a computer model that's doing that for you. Okay? Yeah, so this is kind of the typical setup. And one thing that's really important, a lot of processes in the industrial world are what's called continuous. They run all the time. And so like polyethylene, for example, you're running all the time. You may change grades, but it's running most of the time. Refineries run all the time. But in some process, you also have batch, where you just make it in a kettle, and then you take it out of the kettle and go use it. And it's very hard to figure out how to do both batch processes and continuous together. So models continue to get better and better, so you can model both types, because a lot of plants have both types, and that's a big challenge to figure out those two things. So that's a plus of some of the new models that are just starting to come out. Another thing is that conceptual design. So that model can help you with like early experimentation. Now I'm trying to think, what kind of unit should I build? And these are some big considerations. I want to think overall, what's the capital cost? Was I given $5 million this year or 25 million? I got to fit that in, or how big what kind of scale can I do? You need to think about energy, and this directly correlates, of course, to CO2 for the most part. And then you need to think about how your exchanger, this is a critical, the heat exchanger is running basically, and the efficiency there. So these are just some of the tools you can use to figure all that out, either the economic analysis, looking at your energy, all the different types of utilities that you use, and then very specific in how you use your, there you go, that's the jolted, she said, yes, the exchanger, because the heat exchanger is a really critical part of the unit as well. So you can optimize each of these pieces. And it helps a lot when you're getting ready to build a new unit. You want an idea about what is the best thing. Oh, yes, sorry.
For the World Economic Forum, one of their goals was to reduce debts. How would they?
To reduce debt?
Debts.
Sorry, I'm not here.
Debts.
Oh, deaths. Oh,
Yeah.
oh, sorry. Sorry. This said debt, like with a B, and I'm like, what? Wait a minute. Okay. No, to reduce deaths. Yeah. Well, okay. Multiple levels. One is you need to improve productivity. You can improve quality of life. So that was an aspect of it. And pollution is a big factor in some of the efficiency of these processes as well. So that was one of their things. And CO2 is the later piece that they're looking at as well in terms of air quality and improvement of the overall environment. So those are the considerations. Yeah. And this is just some examples of companies, what they do. So for example, you can use tools to get more capacity out of your unit and not have to spend more money to make it bigger. You just are able to run it faster. Or you can get a product to market faster, and that saves a lot of money. And it really depends on the type of product you're making, but you can use these tools to do it. Kinos is actually an Australian polymer maker, and that's what they did. And then Dow's done a whole bunch of different things, but one example is by using models, they're able to make something much faster. They modeled it and realized, oh, I can make this adjustment, and I'll do that in the plant now, and then they can make something much faster than they used to make. So that's how models can help you with how you do the process. And then let's talk about operate. And hopefully it's not too much engineering stuff, but this is to kind of explain what you do when you do something called advanced process control. So let's imagine that it could even be in the lab, you want to get the temperature right in your vessel. And so what do? You do a little manual adjustment, right? I don't know, if you probably don't use burners, maybe you use hot plates or whatever, but you do some tiny manual adjustment and you hope you get the number right. And then sometimes you don't, and fly up like this, and then, oops, no, then I cooled it too fast. And you end up with very messy because you're just trying to do little adjustments. But if you instead could enter it digitally and keep your temperature exact, much closer, then you get it under control. So you don't have such huge swings in your temperature. And that's what equipment can help you do, and digital tools can help you do, because it knows, oh, I should only tick up a little bit to keep it in this narrow range. And then for plants, once you've done that, I know I'm confident that I could run in this really narrow range. Now I'll go back up to the limit where I am, because I know I'll keep it there. When I was back here, I got so nervous about swinging up and down that I would go over my limit. But here, if I first get it under control, then I can go up to my limit, and you can push your capacity, you can push your operating conditions, whatever they happen to be. And this is something that's kind of fundamental to many units now, called advanced process control. Most chemical plants now, I should say a lot of chemical plants now, use advanced process control to keep the operating window smaller, keep it under control, and then they can run harder because they're confident that they'll stay under their limits. And I use temperature as an example, but when you're running a huge plant trying to make a plastic or trying to make ethylene, the feedstock that you use to make plastics, there's a lot of different parameters changing all at the same time. So this just to blow it out a little bit, these are all the things you're looking at. So temperature is one of them, but you might have pressure, you might have how fast is it agitating, you might have what's happening in a column, you might have what a particular motor or pump is doing. You're getting to the point now that you can't do a simple 2 graph, you can't even do a 3 graph, right? You're getting beyond what you can think about anymore to control all those things. This is where a computer helps, because there's so many parameters. It helps see the relationships between them and get them back in control. And it really is. I mean, I know we've all done the simple charts where you can see relationships, but there's a point where there's more data than you can see any longer. And this is where a computer starts to help out. So these are just examples of all the different kinds of things you can look at. And the reason why people use it is, well, you can obviously reduce the variability in operations, so you get it under control. You might have a catalyst involved, and whenever things fly up and get out of control, you often hurt your catalyst, which is a very expensive component in your operating system. So you really want to be careful about that. So if you can get it under control, you'll be nicer to your catalyst overall. And then you can keep your energy lower. You can maybe get more capacity out of your unit. And also quality. It's not uncommon that you fly up in one of your areas and now you've made an off-spec batch. It's not what you wanted. It's thicker than it's supposed to be or darker than it's supposed to be, whatever. So you get your process under control, and now you're making the clear plastic that you intended to make, or whatever it was that your target product. So that's what's really important about APC. Another area that people are using tools a lot is in plastic scheduling. So I started to mention before, so say you're making polyethylene, it's a unit that runs all the time. But what you're doing is you're adding catalysts at different times to make certain types of a plastic. Sometimes you think about all the films you see, those are mostly polyethylene. Some are glossy, some are not, some are stretchy. You know, there's a real difference. So depending on what you're trying to make. But because one customer wants it stretchy and the next customer wants it really thick or whatever it is. So they want something, a different performance. So typically you just kind of say, okay, I'll make this polymer for 2 days and then I'll switch over to this one. And you do it manually. You kind of make what's called a campaign wheel and say, okay, here's one, then I'll do the second one and then the third one. But you're not optimizing there. You're just saying, well, he asked first, so I'm going to do that one. You don't think about it as much in terms of maybe what your energy swings are when you change from one to the other. Or maybe when you go between the two of them, the stuff that you make in between that's not good material. You waste more, you make more of that. So now there's new tools that help you decide how to run the polymer. And again, there's so many factors here, is that it helps you do a matrix so you can figure out the best way you would run it. And again, it's just applying the tools, all the data you know about all the different grades you've made before, and the energy that it takes. And you can now find the lowest cost schedule. You can still make customer needs. One of the biggest things too is it means you can have less inventory because you're confident that you can make everything you need. So you don't need huge stacks of stuff just in case somebody calls. You know you can make it pretty quickly. So this is a big thing that's happening, and a lot right now on the Gulf Coast. There's a lot of new plastics units that have come up as they bring up new feedstocks based on shale gas. So a lot more plastic plants, and they're using a lot of these tools to now control and be sure they make less waste and use less energy. So these are important tools. Okay, any questions? You guys okay? All right. Then there's machine learning. So I mentioned this, and this is kind of the next step. I talked before about 6 variables, and you think, okay, this is a little too beyond. Machine learning is hundreds of variables, stuff that you have no idea about the relationships. And so those are the new, maybe you've heard the two, analytics tools, and it's basically where you take loads of chains of data, and you begin to see patterns emerge. And it's by it's big data, right? Big data computing, and these patterns emerge. And then you can now figure out that things you're doing upstream of maybe this pump, for example, changes you've made upstream, every time you spike up to 72, the pump gets unhappy and it breaks. And you haven't correlated it every time because it's a combination of when it spikes up and you're running that grade and it's a damp day and all these things, but you can't see all those. So this is where machine learning, big data helps you with that. And so it helps you see those patterns. And a lot of companies are starting to use this, and I'll just give an example. This is a big plastics manufacturer that's based in Europe. They're actually about to build a unit here in the US as well. And they had a compressor in one of their polymer units that they found it went down unpredictably, and it was a big problem. So we took a whole bunch of the data. This was low density polyethylene, so one type of polyethylene. So it took a whole bunch of their data for all their maintenance and all their operations for like the past 5 years, and threw it into the computer to look at all the big data to look for correlations. What is the situation when this pump goes down, and how can we stop it, or when this compressor specifically goes down? And by doing all that comparisons, they learned about conditions, first the conditions that cause the pump to break more often, and then later it was more prescriptive maintenance where you said, you know, the compressor is going to go down, but now I can predict it. I know it can give me some days of warning, so I know when it's going to break. And the plus of that is, I'm sure you guys have seen this in the Gulf Coast, when something unexpected happens, suddenly there's a huge flare up in the, so a unit is misbehaving and you just send all your feedstock to the flare. That's a huge CO2 release. Sometimes it's also sulfur, nitrogen, it can be a whole bunch of things get released all at once. But you're doing it for safety reasons. You did that so it didn't blow up. So when things break, that's often when things happen. So if you can get warned about something that may break, you can say, oh, well, it could break in 27 days, so I'm going to take it down in 25 and fix it. But I'll bring it down in a controlled way, not in something that sends huge flames into the air and scares people, and also means that you suddenly can't make what your customers asked for. You're unable to produce the way you expected to. So you now can plan for it and then change your operating conditions and behavior so that you can you make a change so you run better. So that's one of the ways that digital tools can get used as well. So I feel like you should ask me questions, because I think that this is more stuff than you guys are used to seeing, but that's okay. Anyway, the key thing though is the use of digital tools is meant to help. So it augments what you're already doing. So I mean, we already know this in our daily life and how we use lots of digital tools to get through our day. I mean, something simple, as AI, when you're beginning to spell out a word in text, it gives you some options, right? That's the beginning of AI. It knows what you usually do, so it jumps in and gives you these options. So now it's being applied to much bigger processes in chemicals. And it's a very interesting area, because the combination here of you need to understand the way processes work, and then apply the digital tools. If you just stick the digital tool on it, you won't understand the correlations and what could be impacting things. So what makes it interesting is that now you understand the process and you say, okay, how can I use a tool to help me see through all this huge myriad of data that must be telling me something, but I can't figure it out. And that's where these programs and these algorithms help you see to make better business decisions, better R&D decisions in terms of how to target the reactions that you're doing and how to make the next new interesting material. So, all right, and the company I'm with, I'll just mention, is just a big technology company. They actually grew out of MIT in the early 1980s. It was a actually DOE funded program first to say, we got to figure out what to do with digital. And so they began to develop all these tools, and now gets used by energy, chemicals, and lots of big companies that build the plants as well. So, all right, I hope that, I don't know if it enlightened you or not, but there's an idea about what digital means in chemical business too. And I have an article, if you're interested, just kind of high level review as well, that was in hydrocarbon processing last week, if you guys were interested in it. So, okay.
Thank you for that lovely talk.
Yeah.
Does anybody have any questions for our speaker?
Yep.
I'm just interested to know your point of view on this. So, with the chemists coming up through school, do they learn data science or chemistry, or do you combine the two?
So, hardcore data science, no. I think you need to know how the tools get applied, because first off, the concept of data science, the computer handles a lot more of it now. So I think what's important is what I would call domain expertise, that you understand that pressure is important, the catalyst is important, all of that. So you understand the critical processes. That's why I think chemistry and chemie is really important. But yet you need to be able to use the newest tool to apply that to your process. So that's why it's important to understand it. But just like we've learned, to come through school, you learn about an infrared or spectrophotometer or whatever that you're using. This is now the newest tool to help you do what you do. So it's very helpful to understand it, because I think it's going to be fundamental, certainly to any industrial career, and more in university work as well. Yeah. Yep.
Is there much opposition to the digital transformation?
Opposition? So I should repeat that, right? Much opposition, because you wanted me to, yeah, okay. Opposition, you're saying? I think, initially, that's why I tried to address a little beginning. Initially, people were worried that you'll take my job away. It really isn't that. You can't, it'll make you more efficient is what it is. And that's really the point, I think. It's like a tool to help you do your role better. But the way the tools are being employed, artificial intelligence, people get nervous about that. That really just means beginning to interpret your big data. And one thing that's really critical in chemicals, in energy, is safety. And so what we're finding with companies is they're extremely careful before they proceed with anything, because you've got to be really sure of the safety. And so a lot of what we do in this area is more reflective. We watch all the data and then see what you can do to make adjustments, but they're minor adjustments within very strict safety confines. So that area, I think, there's been some negative concern initially, but people getting much more comfortable with that. And then on the positive side, it's like I mentioned before, you can use these tools to better monitor CO2, to watch how you use flares, which, as I say, these huge flames in the air. Much better now about how we think about flaring and avoiding it, because we have a better understanding of how processes work. So I think there's a lot more positive here than the negative concerns. Yep.
In terms of the business side, is there any type of company that has benefited, you think, more than others, different sectors, large companies, small companies, and who has kind of taken on digitalization?
Yeah, it's an interesting. Yeah, it's an interesting question. Certainly, a lot of the big, both chemical and refining companies have done a lot, but not everybody. It's interesting because you still can go into companies where they say, well, we did advanced process control, for example, over here, but we ignored the other half of the plant, and they still have guys out there turning knobs. It's kind of hard to believe, but that stayed probably mostly in the spec chem business, where there's a lot of proprietary concerns, trade secrets. They don't want to let anything out, so they've been a little more nervous to put something into the machine. But they're getting over that. Cybersecurity is much better, and how we do data sharing is all much better. So I think there were initial concerns in that sense. Most refineries worldwide now use some kind of APC. they probably have a little better penetration than big chemical companies, well, then I should say overall chemical companies. But the big majors, if you can name any of the top 10 in the world, they're all using a lot of digital tools. It just may be how deep into their business they're going. As I say, specialties is kind of the last area where people are getting nervous. But in contrast, though, Japan is a very much a spec chem business, and I was there in the fall. They're using tools in a huge way about efficiency, because they know to be competitive, they need to be as efficient as possible, and they see the value in using the tools to do that. So they've gone in deep with spec chem now. So yeah,
I have kind of
a follow-up. Okay.
question. Have any companies strictly just started selling their data? I know trade secrets are a big thing.
Yeah.
But could that be another financial opportunity? I mean, what came to my mind is something like Merck or Sigma Aldrich selling anytime you draw a structure and they don't sell that company. Sell that company.
The particular one.
Yeah, so if that
Yeah.
came off the law, would they then sell that data on to another company who might profit from making it?
Yeah, potentially. I think there's opportunity. And I'll tell you again, the Germans are looking at that. So Wacker is looking at setting up a digitally based opportunity company. So yes, people are trying to figure out how to do that. But they're hesitant with the data side. Like you say, there's a trade secret. And one big challenge, and this is true anywhere. I mean, there have been a lot of chemical plants all over the place. They're not actually identical. They say they are, but they're not, you know. So the value of that data to the next unit, it's not complete. I'll just put it that way. And so I don't know how far that can go, because you end up just having to customize. And you think you won't, but you will, because, you know, there's a little more nitrogen in that stream than there was in that one, and whatever it is. But yeah. Yeah, right. Is there another one over here? No, were you? Yep. Okay.
Did you have a question, Peter?
I had a question.
Okay.
So in your presentation, you had mentioned the matrix, and I was just wondering, how could they use that tool to show how much energy they should be saving, or how much waste they should be saving from what they were trying to do?
Yeah, well, so in the energy one specifically, often you have a lot of different energy sources coming into a chemical plant. And steam is one of the biggest things. You need to generate steam to create heat all over the place and to drive processes sometimes. Well, how do you want to make that steam? Do you want to, if you're in a chemical plant, maybe you have some extra feedstock you could burn, or do I want to use electricity to do that? Or do I want to, I mean, again, you could have just methane that you have access to natural gas. So there's a lot of different ways you could do it. And what you're doing is a comparison of what the heat value is for how well it works in the process. So again, it's the computer helps you, or the algorithm helps you do that comparison in a better way. Particularly because it may be that in your particular location in Kansas, it's cheaper to buy electricity than it is to burn natural gas, for example. It really depends. So it lets you do that full comparison to think about relative cost. And as I say now, it also has in it to consider, what's my CO2 outlet? Because even though we're not yet charging for carbon, at some point that's going to happen. It certainly is something people are thinking about. So now to say, even if it's cheaper to buy it here, but I generate more CO2 by using this, maybe I don't want to do that, because I'll exceed my CO2 target that the company has, or something like that. But these algorithms let you do that comparison. And it's easier than you trying to figure it out and get out your calculator and do, it's too many variables to really see, and it helps you do that better.
So I had a question more about towards your, you're talking about machine learning.
Yeah.
And I was wondering how saturated is the market with that, if all companies in general?
There's a lot of people talking about it. The one struggle is, I've got a colleague, I wish I could remember what he said, but it's something to the effect that with a lack of domain knowledge, you don't know what to make sense of. So there is a correlation between how many sunny days in California and whether or not trains are on time in Norway. Does that make any sense? Who cares? But you have to have enough knowledge about the process. So that's the challenge, is a lot of people are talking about machine learning. Oh, apply it here, stick it there. But you have to know what you're working on. And that's the hard part here, is finding the right algorithm that understands the environment that you're in, whatever environment that is, and whether or not that means you're typing German into your phone versus English, or you're running a chemical process or a mining company somewhere in South Africa. you need to have the right kind of tool for that kind of operation. And that's getting better. It used to be that anyone who could do math was trying to throw big data solution at you. And now they're saying, okay, no, wait a minute. It's big data who understands how mining operations work or how a refinery works or something. So it's getting better in that sense. But I think people are learning to be more cautious in their tools because it's not just math. You have to understand more about what's going on. Yeah.
So I had a question
Oh.
about that. In regards to the particular problem you were talking about with the compressor failure for the LDPE, was that a project that Aspen was doing, or was that?
No, it's actually, so it was Borealis was having trouble, their low density unit, because the market had been very tight and they hated that, oh my gosh, my unit keeps going down unpredictably, it's driving me crazy, I want to be able to control this as much as possible. So they came to Aspen and said, can you help us solve this problem?
So is Aspen more of a consulting firm, or how much is Borealis doing the project versus how much so you've got to teach them how to use these tools, but then they've got to be able to use them.
There's a service
in-house.
aspect to the business, because while they can buy a software program, so let's think you install a software program on your computer, but if you can't figure out how Excel works, you need some help with it. It's a little deeper than Excel to get these tools to work. But yes, we spend quite a bit of time teaching people to use it. Also, there's value in how you package the product. Just think again about the user interface when you use Excel. There's certain workarounds now that just make sense. Well, that's a lot of what Aspen's been doing recently, is to package it in a way that makes sense to a polymer operator. Oh, well, that's easy data. I know how to pull that. It follows. So that's where a lot of the work has been done at that end. But it does take some service to apply. And what customers do is they buy the software, they license the software to use for a certain period of time. So that's the typical business model across the industry. Yeah.
Any more questions?
I think I see one over here.
With respect to the use of digital technology in chemical synthesis, how do we expect that to impact the average consumer in everyday life?
Consumer. Oh, okay. All right. Do I need to repeat that one, right?
Yeah.
The impact of digital tools in chemistry and how it impacts the consumer. Well, interesting question. I think that, the main area, I think, as I mentioned, is maybe faster to market. So in terms of changeover of products, I like to think that we'll make them better. We'll make them more efficiently, because that's one of the big issues, I think, is that when certain raw materials or energy is inexpensive, you're not careful with how you use it. So I think digital tools can really help you find a more energy efficient way to run a process. And so in the end, we're using less energy, less CO2 generation, we're being more efficient. It may not be purely a financial driver, but I think it's a better outcome in the end. And that's what I'd like to think, is that we'll go to more efficient processes. We learn to not waste so much. And that will be a difference that we see, is that we're not generating so much CO2 or so much landfill or whatever.
Would that then suggest that we have more resources available for alternative use?
For alternative, more sharing. Yeah, I think that. It's kind of a big picture thing as opposed to localized. Because I think for a company itself, they're thinking faster to market, cheaper. I can get more out of that same vessel that I built 10 years ago. Now I can make 20% more. That is certainly the initial driver in profitability. Yeah.
Well, let's thank our speaker one last time. If you're interested in more information about future seminars, please do sign up on our sign-in sheet. Give us your email. Take a flyer. Got a few here. And there's a little bit of food left, so help yourself.
And if anyone's interested in an article kind of background on more on digitalization, I have some more here.
And if you would like electronic copies of those, also, please let me know.
Okay. You kick out of here.